what I'd like to talk to you about today is secondary data analysis in biopsychosocial research. And the figure here, for those of you who are too young or either too young to know or don't have, did not see British kind of comedy growing up. This is Mr. Bean, is the secondary data analysis guy here. Let's go. So the first thing I want to do is I want to bound today's discussion. So today I'm going to be talking about general population-based surveys and cohorts that are designed to answer broad questions about health. And so what that means is that most of the types of issues that I'm going to be talking about are referring to samples in which they're sort of the sample is kind of general population, that is, it wasn't recruited from a particular clinic or because they have a particular health condition. This will be, the reason for this will become apparent later. And then again, within these population-based surveys and cohorts, I'm going to focus on those that assess this a wide range of constructs, which of course in MeWe, this is the type of thing we're very interested in. What I'm not going to be talking about today, obviously, is I'm not going to be talking about primary data collection, given the name. I'm also not going to be talking about analysis of data from things like experimental studies or qualitative studies or administrative health records, but I think that many of the principles that I raised today you could apply there. But I guess I just want to make it clear sort of where I'm drawing the bounds of the discussion for today. So the three things I want to talk about is, the first is I want to give some guidance on how to find and access existing population-based data for biopsychosocial research. Many of you may be well-versed in how to do this, but for some of you, you may not know exactly where to start. So I want to make sure that we all have a good foundation on how to actually access this data. The second part is the heart of the topic, where I work, or heart of the talk, which is around deconstructing your data, specifically deconstructing the idea that biological, psychological, and social variables do not all have the same sources of error, and what that means for the kind of work we like to do. And then finally, I'll close with some additional challenges, as though part two is not hard enough, but some additional challenges that we have as folks who are interested in minority health and health disparities research, which has to do with measurement, non-equivalence or equivalence. So first part, understanding secondary data resources for biopsychosocial research. So the first thing to know is that existing data resources that can test biopsychosocial research questions have literally never been more abundant. So I don't know how many of you read Wired magazine. It's one of my favorites, but every issue they have a section they call it Expired, Tired, and Wired, whereas of course Wired is the new hot thing. So if in terms of data, when we think about like data, what's expired is collecting cross-sectional self-report data on samples that are quote unquote representative, but still somehow overwhelmingly non-Hispanic white. What's tired is incorporating a one-time venipuncture into a cross-sectional survey to measure something like gene-environment interaction. And what's wired is creating multi-level data sets that link survey data to external data using like geographic identifiers, maybe even individual level identifiers, plus incorporating measures of physiologic systems, like maybe this is immune functioning or metabolism or sleep, right? That's the hot stuff, right? That's the, not just the future, but that's where we all sort of want to be that's the place that we want the most novel, that's where the most novel work is happening, is with those types of data sets.
Mezuk.
Oh, sorry. I think someone's unmuted. Could everybody mute themselves? All right, thanks. So you might ask, why is there so much free data these days? And there's kind of four reasons. The first is that funders, especially people like NIH, say that you've got to share your data as a condition of getting, if they'll pay you to collect primary data, but that condition of funding is that you've got to share it. The second is that data sharing systems, data sharing is really essential for the conduct of meta-analyses and systematic reviews, which, things like the Cochrane Review and other types of efforts have really, just pushed the field of health research to say, like, this is how we're going to make decisions. This is how we're going to understand what's a real effect and what's a spurious effect or sampling error. The third is that data sharing is a core principle of open science. You've heard me talk about this during MeWe and ad nauseum. And then finally, just the internet, right? Like things, we have both computing power, we have the ability to be connected to people in a way that we didn't ever used to be before. I mean, the very first paper I ever wrote, and I'm not that old, you know, I had to send it into the, I had to send a hard copy into the journal along with a CD that had an electronic copy of the paper. And, you know, and that was in let's see, no, that would have been 2006. So there were still journals that was the type of, that's how you got studies submitted and published. And of course, that would, something like that would be unheard of today. So there's so much free data, it's very accessible, and we really have the internet to thank. So I wanted to kind of just illustrate how much data there is now using an example from ICPSR. I think most of you will have heard us talk about ICPSR through MeWe in the past. What's important to kind of why this table is interesting, I guess, is that the ICPSR stands for the Inter-University Consortium on Political and Social Science Research. That is, they do not, in their name, claim to be an archive of health data or even an archive of data that has like biological markers or anything like that. But, you know, I went to ICPSR, the ICPSR website yesterday, and I ran 3 searches. I searched for the term biomarker, metabolism, and genetic. And just from those simple terms, right, which, you know, aren't even like Boolean operators or anything like that, there's literally hundreds of data sets that are in an archive of political and social science research that have data on biomarkers or have indicators of metabolism or have some information on genetic information. So I know that if you were to go and do a more exhaustive search, you would find there'd be so much. So that's just an example of just how much data there is that's out there. So, but the other thing that's important to understand, and this is a little bit evident from the names of these studies. So if like you look at the studies, you've got, for example, you know, the panel study of income dynamics. Not a study that you might think, based on the name, would have genetic data, right? And it's true, when they started that study, they didn't have genetic data, right? But now they do. And you could compare that to a study like the Survey of Midlife in Japan biomarker project. Like obviously biomarker is kind of a core part of what that study is. And so what I mean by that is that there are different ways in which data that we would call that have biopsychosocial variables in them. There's different ways that they come about. So there are established self-report surveys, or maybe a cohort that's focused on psychosocial factors that decides to begin assessing biomarkers, whatever we mean by that, right? So that's one way that these studies come about. It could be that there's an established genetic or clinically oriented cohort study that decides to begin assessing psychosocial factors, whatever we mean by that. And it could also be that there's a case that that psychosocial and biological data were designed to be collected at the beginning of study initiation. Like even at the very beginning, they knew they wanted to measure all of these types of variables. And so I would, for example, there are different examples of these. So for example, the epidemiologic catchment area study, which is a survey I had direct involvement in, is a cohort study of stress and mental health. And in the 2004 data collection, we started collecting biomarkers. But that data that cohort was established in 1981 and didn't draw blood on anybody until the year 2004, okay? You can compare that to something like the ERIC study, which is a study of atherosclerosis, or even the Framingham study. These were cohort studies that were focused on, in the case of ERIC and Framingham, trying to understand risk factors for cardiovascular disease that have, as data collection has gone on, have really expanded their assessment of psychosocial factors. And then the third, version here is that a study that was designed from the very beginning to collect both psychosocial and biological data something like the Handle study, the study of Latinos, the PATH study, the Jackson Heart study, and even Cardia to some degree would all qualify as one of those. But what's important is that to kind of think about as a secondary data, from the perspective of secondary data analysis, is that these are three very different origin stories. And so while all of these data sets listed here have biopsychosocial data, that doesn't mean that they're interchangeable, that the origin story sort of didn't shape how it was collected. Let me give you an example of that using Cardia. So what I did to create this slide is that I went to the Cardia website, which is hyperlinked here. Again, I'll give you these slides when I'm done here. I went to the Cardia website and I went to their user guide information and said, oh, these are the measures that we have, and you'll see that they have on the left-hand side, starting in 1985, they have all of these fantastic laboratory measures, including lipids, and they've measured lipids every time for a total of 10 time points from the year 1985 to the year 2020. On the right, this is like page 3 or 4 of this document, you'll see the psychosocial questionnaires. You'll see they're a lot more sparse. And if you see all the way at the very bottom, you'll see the measure of loneliness. And loneliness was measured twice in Cardia. So, even though we would consider, and it wasn't measured until the first time until 2005. Sorry, loneliness was not measured for the first time until 2005. So again, even though Cardia certainly has biological, psychological, and social data, the depth of biological data, specifically biological data related to cardiovascular disease, is much greater. Like if you think about it, the resolution that Cardia has on cardiovascular disease is much, much greater than the resolution Cardia has on psychosocial characteristics or on loneliness specifically. And I'm not trying to call out Cardia. You could flip this around. The Baltimore ECA study has a much higher resolution on mental health measures than it does on biological measures, right? So it's important to kind of just have that sort of understanding in mind, is that different, even though both studies have the same measures, they don't necessarily have them with the same degree of depth. And that may have, that should probably have implications for your choice of whether or not you want to use that data for your study. ACPSR is one data archive. Of course, I like it because it's based at the University of Michigan, but there are other repositories for biopsychosocial resources that I just want to kind of put out here, make sure people sort of know about. So I alluded to this when we were talking about Cardia, but there are 4 kind of meta questions that I would encourage you to work through when selecting a data source for a biopsychosocial research project. The first is just how frequently were these things, that your measures of interest, assessed? So it's particularly one of the advantages of a study like Cardia or Handles or Framingham or what have you, is that those cohorts have, Cardia started in 1985. Most of you probably weren't even born in 1985. Can you imagine how long it would take you to get you can calculate it, how long it would take you to you don't have to live through Cardia. You can just download it today, right? But other people lived through Cardia. They lived through that entire follow-up period. So you should want to be taking advantage of the tremendous, the longitudinal data that people who've been in the field for literally decades have been collecting when you're thinking about your types of projects, because the cross-sectional data is just not sort of the leading edge of where the field is. So you want to know how frequently were these things measured. You also want to know, and this is something that kind of happens a lot because biological data is kind of expensive to collect. So were those measures assessed on the entire sample or only a subset? And if it's only a subset, how is that subset chosen, right? So you kind of want to understand, you might get excited and think like, oh, I've got, whatever, methylation data. I've got this incredible measure of, I don't know what the heck it would be, like loneliness, but oh, it turns out that only people at the, wave 5 were, had these biological methylation measures, for example. And so like that kind of stuff happens a lot. And so as you're working through, is this the right data set for my research question, you're going to need to, don't be surprised if that kind of stuff happens. You know what I mean? That there's subsets of people that received the particular biomarker that you're interested in. I say biomarker, even though it could be psychosocial measures, because the biomarkers tend to be so much more labor intensive and expensive to collect. This is where studies tend to sort of have a little bit higher threshold or select potentially samples to be assessed. The third is, what was that mode of data collection of the biopsychosocial measure? So was this telephone or self-administered or CAPI or face-to-face? We know that mode of interview does affects how people answer questions. So you want to know what it was. You want to know if the data were collected during the same visit, or maybe they were collected on different times or different days, and were they all collected in the same place? Where, was the biological data collected in the clinic and the psychosocial measures were collected in the home? I'm not saying that there's a right answer to these, but you should know this, because I think the challenge with one of the challenges with secondary data analysis is trying to imagine what that field work was like, because that's really what you want to do. You want to be able to talk about these data sets as though you helped collect the data, but you didn't, right? But you also don't want to live, or you don't want to work through, be in the field for 25 years trying, like Cardia has been in the field, right? Or 35 years, pardon me. So it's important that you really spend time trying to understand where these data came from and how they were actually collected. And then the last thing, I think this is more important for older studies, that is studies that, so for example, with the ECA sample, because our priority was the psychosocial measures, that in order to participate in the ECA, you needed you were asked to participate in the survey, and then you were additionally asked to participate in giving blood. And if you said no to that, then you were asked to just give a DNA sample with a cheek swab. That is, it wasn't a requirement to give a biological data in the way that we implemented it in the ECA sample. Nowadays, people kind of just lay it all out, and we're like, if you want to be in the study, it means there's going to be a blood draw, and there's going to be a questionnaire, and we're going to collect this other data. So I think it's less of an issue nowadays. But certainly when we were first introducing the collection of biomarkers into an established cohort, we didn't want to scare people off by sort of saying, well, if you still want to be in the cohort, now you've got to give us blood, because we were really interested. We still wanted to talk to people even if they didn't want to give us blood, right? So I think it's just it's important to kind of, again, understand something about how the data were collected. And where will you find the answers to these questions? They're going to be in the data users guide and the related documentations. You've got to spend a lot of time with those before, I would say, even before you kind of do maybe do some descriptive, does this variable exist in this data set? But then stop. Don't get excited about that. Stop and start spending some time with the data users guide and documentation, or talking to the people who collected that data in the first place, or talking to somebody who's published on that data. Try to get connected to them. This not only does this help you build your professional network in terms of reaching out to people who actually collected the data, it helps. It's worth the time in just sort of saying, I'm excited about your data. Are there, but I just kind of want to know exactly, where do you recommend I get started with this? And or as questions come up, to make sure, because sometimes documentation, there is incorrect. And so if you see something that doesn't quite land right, you want to make sure that you're able to have communication with the team. Don't be afraid to reach out to them. All right, so that's part one, which is how to get access to data that's appropriate for psychosocial research. I now want to turn to the variables that are in those data sets that you may be selecting. So I want to talk about a variable typology. And before I tell you my proposed typology, I want to just go over what is a typology in general. So typologies are just a form of classification. That is, and what is classification? Classification is simply a means of organizing things that are alike into groups based on features that we think of as kind of being fundamental to that type. So like if you look at this phylogenetic tree, there are bacteria and archaea and eukaryota, right? And so like these are defined by, do you have a true nucleus or not, and you're a multicellular organism, right? These are the type that is a fundamental feature that defines these different groups. Now, typologies are useful if and only if knowing that something is a member of a particular type, that knowing that they're a member of this group tells us a lot about that thing, even if I don't know anything else about the specific member itself. So for example, you might not know anything about cats, but if I told you that cats are a eukaryote, you would know that, well, cats must be an organism that has a true, true nucleus, and right? You would know that thing about them already, right? Or if I told you a cat is a mammal, remember back to biology, you would say, oh, well, then it has fur and it must, nurses animals and right? You would know, or it nurses its babies. You would know a lot of things about cats, even if you've never seen a cat, even if you just knew the definition of a mammal, right? So when it comes to this idea of a typology as it relates to biopsychosocial research, a variable typology would be useful if it could provide guidance on how to approach these types of variables and what pitfalls to avoid for these types of variables as we're working through them in our research. So that's what that's the function that I hope a variable typology, if successful, would achieve. And then the last bit of preamble before I sort of go through this actual typology is just reminding you of something which you already know. That is that there is a very kind of fundamental relationship between reliability, that is, how test retest reliability, for example, or measurement variability, and validity. That is, if a measure is not reliable, there's no hope that it could achieve validity. Okay, so like if we go from the right, you've got arrows all over the bullseye. The middle one, you have arrows in one spot, but it's not at the bullseye, right? So yes, you can measure something the same every time, but you're not measuring the thing you think you're measuring every time. So you're consistent at least, but you're not consistently measuring the truth. And what we hope is that our measures are both reliable and valid, that is, they are consistent, and that they are measuring the construct that we actually think is that we're hoping to measure. Our problem, of course, one of our problems in terms of psychosocial research or biopsychosocial research, is that not all the contracts that we're interested in have a gold standard against which we would even know, are we on the bullseye, right? So if the center of the bullseye is the gold standard, most things like that don't exist. Like, what is the gold standard measurement for depression? What is the gold standard measurement for life satisfaction, right? What is the gold standard measurement for discrimination? These things don't exist. Those concepts, that construct of gold standard is not really useful for us. And even if that gold standard does exist, it doesn't mean that it was included in your selected data set. So I guess what I give all this preamble to say, you've seen figures like this on the left before. You've been taught about the relationship between reliability and validity. And I'm about to complicate things because the world is more complicated than that, because this assumes a world where there's a gold standard. I guess I had one more bit of preamble. So the other thing that you need to kind of remember is that your statistical software program, no matter what it is, does not know what it means to conduct a biopsychosocial research project. What do I mean by that? So on the right here is just a screenshot. I use Stata. So it's right as a screenshot of the variable creation window within Stata. So programs like Stata, they are completely indifferent to things like mode of data collection, measurement schema, sources of error, etc. What I mean by that is Stata understands the following variables as being all of the same kind. That is, they are all numeric variables. The ID variable in your data, age, height, miles, C-reactive protein. extroversion, blood pressure, number of friends, grade point average, number of hours spent on your phone, and birth weight, right? All of those variables to Stata are numeric variables, period. But the amount of the sources and the amount of measurement error across those variables are very different, right? And so I tell you this because to just kind of drive home the point that your statistical program, the answer to what to do about these different sources of error between biological measures and psychosocial measures does not exist within Stata or R or SAS, but rather the solution is within you as an interdisciplinary scientist. So what I'd like to now spend just a little bit of time talking about is a variable typology. And I'm going to propose 5 types of variables are relevant to biopsychosocial research. So the first type of variable is a variable that is assessed by self-report, but there is no better, or we might call gold standard, assessment of that target construct. So for example, opinions, beliefs, preferences, emotions. These are things for which we only assess these types of constructs by self-report, and there is no gold standard assessment of any of these things. We typically measure these using quasi-continuous scales. The main sources of measurement error are issues that are relevant to all self-report data, like recall bias. And there may also be the fact that there might be multiple sort of quote unquote validated scales to choose from for that said construct, right? So if you were looking at depression, there's probably 8 depression scales out there that are kind of regularly used in health research. How do you know which one to choose, or how, in the case of secondary data, how did the people who collected that data choose? What were they concerned about? What sort of factors went into their decision making, right? So it's important to kind of think about that. Some ways to address these sources of error for these types of variables would be to analyze multiple measures of the same, or let's say related construct in your analysis. So you can try to deconstruct or decouple the exposure outcome relationship into the construct of interest and the measurement of that construct, right? So for example, we've done work in the health and retirement study on this, using this exact approach. So the health and retirement study includes 2 measures of depression. It includes the 8-item CESD, and it also includes the short form composite international diagnostic interview for depression. So these are, again, both depression scales. They actually have relatively poor agreement, and that is both good and bad. It's good in the sense of if it is the case that the relationship between depression and, let's say, fall risk, if that's consistent across both the SESD and the CD measures of depression, then that gives you confidence that it's not just an artifact of the way that depression was measured. However, if the fact that the SESD and the CD are identifying different groups itself means that we have to sort of really be careful when we talk about our conclusions, like, well, what does it mean, like depression, right? Well, depends on sort of what you want to talk about the construct, not the measure, right? There's where it's very unsatisfying to say the measure of SESD was associated with fall risk. What you want to really say as a scientist is depression was associated with fall risk, right? But if you don't have multiple measures of a variable that is assessed by self-report and for which there is no gold standard, it's very hard for you to be able to do that. So that's the first type of variable. Again, this is a variable that must be assessed by self-report because there's no other valid source of information. You can compare that to a variable, the second type, which is a variable that can be assessed by self-report, but for which there is another source of information that may be more valid, like a more valid measure of that construct as it relates to your research question. So you could think of an example here would be a history of medical diagnosis, right? I could ask you, have you ever had diabetes, right? And you would probably be able to recall that. But I could also ask you, how many times have you been to the doctor in the past year? I get a feeling your recollection on that will not be as good as if I just looked at your healthcare records, right? And saw every time somebody billed for seeing you, right? So I can ask you, and you can give me an answer about healthcare utilization, but there is a more valid source of information about healthcare utilization, which is actually your medical record, right? So again, we typically ask these types of questions, again, of this type of variable where we can assess it by self-report, but there's another source of information. These are usually things like, kind of frequency or categorical scales, usually over a specific period of time. Again, the problems are, that there are multiple issues of, or there are all the same problems with self-report data, and there might also be multiple more valid measures to choose from. So again, the sources of measurement error are, again, there's not a gold standard necessarily for healthcare utilization, but there might be multiple, because are we just talking about physical healthcare? Are we talking about emergency care? What about dental care, right? Does that count as healthcare utilization, et cetera? You get the point. So some strategies for addressing measurement error for this type of variable are, you want to try to demonstrate that your measurement strategy is a reasonable proxy, that is, it is strongly concordant with whatever this more valid measure is. The way that I've done this, and other people do this, is maybe you link the survey data to external data sources. This is again where the future of the field is in linking data sets. If the health and retirement study, again, as an example, is linked to Medicare and Social Security, and it's geocoded, right? So there's lots of, so yes, they ask about neighborhoods, for example, but you can also you can get access to the geographically coded data on the health and retirement study, right? And so depending on your research question, that might be, those geocoded data might be more valid relative to the neighborhood self-report data. It doesn't mean it's automatically more valid. It's really kind of just, it's all oriented as it relates to your research question. Okay, so again, that's the second type of variable. It's a variable that can be assessed by self-report, but for which there is another source of information that may be more valid. There's a third type of variable that is a variable that can only be assessed through a biological or clinical test. That is, you cannot ask somebody about these things, the data that's contained within this variable cannot be assessed by self-report. So for example, your white blood cell count or your genotype or DNA methylation, right? The only way you can get this information is through a clinical or biological test. I know this is obvious, but I need you to understand, as far as STATA or R or SAS is concerned, your white blood cell count is the same type of variable as the number of times you've been to the doctor in the past year, which is also the same type of variable as your score on the psychosocial or the perceived stress scale, right? Those are all continuous numeric variables as far as STATA is concerned. But they have very different sources of error, right? They're coming from very different places, and they're representing very different constructs. And so that's why I want us to decompose these variables, because the statistical software we use, it treats them all the same. So sorry, back on track. So again, this is a variable that can only be assessed through biological or clinical tests. The measurement strategies, this might be, there's lots of different tissues that we collect data from. Blood and saliva are most common. Sources of measurement error with these types of variables are that some biomarkers are influenced by the time of day, the fasting status of the participant, the source of tissue, the type of assay. Some of these biomarkers are sensitive to those types of things, and some are less sensitive to those types of things. There's also differences in the sensitivity of the actual assays that are used to estimate, how much CRP, for example, has the person made. So what are some strategies for addressing these sources of error? If you're collecting data, again, which in this case you're not, but you need to train your staff on principles of data collection. You need to, and most of these big cohort studies do this. They work with established sample collection or processing vendors. And my big tip here is that this is a field that moves quite fast. And so if you are not an expert in this type of data, you must collaborate with those experts, because they are the ones who know how to, what am I trying to say? Is it they have they have exposure to the jargon that's in this field, and also have knowledge of how to analyze these types of data that is just very hard to get from reading scientific papers that include biomarkers. Like you've got to talk to somebody. I say this from myself. Like when I've done studies including biological markers or genetic markers, those are both the most difficult papers to write, but they're also the papers that are the most collaborative, because we have a lot of conversations about, and what does this mean, and how do you know that's what it means, and what does it not mean, and I learn a lot as a collaborator on these types of projects. Okay, so that's the third type of variable, variables that can only be assessed through a biological or clinical test. The fourth type of variable is a variable that can only be assessed through an elicitation or a challenge. So in this category, I would put some biological measures, like for example, an oral glucose tolerance test or HbA axis stress reactivity, right? But I would also put things like cognition, right? So like a test of processing speed, visual acuity, right? Like viewing, like a vision test, right? You don't ask somebody how good is their vision, you give them that thing, whatever, I'm sure it's got a formal name, that you look at the ophthalmologist, right? That's a measure of visual acuity. Even the types of things that economists do, where they do these experiments to identify revealed preferences. Like, so you tell me you like this type of toothpaste, but if I, kind of do these different experiments, I can actually see what you're really interested in, right? So all of those are things that you cannot ask somebody about. You don't ask somebody about their memory, you test it. You don't ask somebody about their stress reactivity, you ping the system, right? You stress them out to see what it looks like. And so again, they must be assessed through an elicitation or challenge. The measurement of these is always time consuming, and it almost always requires highly trained interviewers to administer. This is a place where reading the documentation is going to be essential to understanding how these challenges were done in the data that you're looking at. You need to be aware that there are massive practice effects, particularly for things like measures of cognition, and even for things like one-time deceptions, like the True Social Stress Test. There are also interviewer effects that you should be that could be potential. And so you would, as you're reading the documentation of, so for example, the midlife in the U.S. or the MIDAS study does an HbA axis, has measures of HbA axis reactivity. So you want to know, was it always the same interviewer who did these, or how was the system, how many people sort of stopped the in this case the stressor before the trial was over, et cetera, right? So it's important, given that these are the sources of measurement error, you want to look through that documentation again to try to really understand, well, how was this data collected, right? How was this, because it had to be, versus just saying, oh, that they were a 7. Well, what does that even mean, right? The other thing, again, ways to address these sources of measurement error, again, this wouldn't be something that you would be doing, but you would be looking for data sets that had done this, that had included multiple practice trials. This is particularly important for cognition, or had used a potential balanced design for a challenge task. So those would be sort of the best things to look for these. And the last type of variable is one that I think we don't think about enough. And this is a variable that is assigned by the investigator, and that is, by you, through some sort of operationalization in which a concept is being applied to the original data. So an example of what I mean by this is the concept of high inflammation, or depressed, or lonely, right? Or social disadvantage. When you take a blood sample, so high inflammation, that might be represented in lots of different ways. So you might have your conceptual, I'm interested in inflammation, but the marker you have of that is C-reactive protein. Well, C-reactive protein is not the only marker of inflammation, right? Inflammation is a much more complex process. And then you take the single marker and then you say, well, if it's above 3, that means high inflammation. And then everything below that means low inflammation. Okay, well, now not only have you taken this really complex thing, which is inflammation, and reduced it to a single marker of this broader idea, now you've dichotomized that in a manner that's now separating the sample into high and low groups, right? Same thing with depression or loneliness or social disadvantage, right? So the sources of measurement error for these types of variables are obviously loss of information through categorization, the fact that the threshold might not be appropriate for the research question or the sample that you're working in, and coding errors, right? Like this stuff happens, you know, and so it's important to kind of just understand when you're not going from, when you were starting to manipulate that data, or if you're using a data set that has a variable called high inflammation, you should double check that. Like I would double check that if I were you, right? I mean, I've used, I won't name names, but like I've used the existing publicly available data and tried to recreate some scales that I didn't, this is a job strain. This is work we were doing on job strain. I guess I'll just name it. This is in the health and retirement study. So we were trying to create this variable on job strain, and we could not. We were following the instructions in the code book, and we could not create the variable as we were expecting it to have. I had 2 different analysts work on this. I finally wrote the health and retirement study, and turns out there was an error in the code book. Okay, so these things happen. So some strategies for assessing these sorts of error, setting aside the coding errors. So that is, but if you're going to apply a threshold, is that you should test multiple thresholds. So maybe you have mild, moderate, and severe depression, for example, to evaluate whether your inferences are unduly influenced by this assignment strategy. Because again, this is a variable that you have assigned to the observation. It is not something that is intrinsic to the observation. What was intrinsic to the observation was whatever their measure on the CRP assay was. But then you took that measure and you turned it into this construct, high inflammation, right? And so that's a different type of variable than these others. So this is the summary of this part of the talk. And given where I am with time, I guess I might pause here and ask for questions and then do the rest of this on Thursday. So again, just to summarize, so these are, I'm going to propose that in any data set that you would use in biopsychosocial research, there's the potential for 5 types of variables. The first is variables that must be assessed by self-report because there's no other valid source of information. Variables that can be assessed by self-report, but for which there is another source of information that might be more valid. Variables that can only be assessed through a biological or clinical test. Variables that can only be assessed through an elicitation or challenge. And finally, variables that are assigned by applying a concept to the original data. And when you download that data set from ICPSR or what have you, and you start to kind of map out your research question onto that data, I would encourage you to think about this typology and sort of say, what type of variables am I dealing with? Because I think at least when I started off in my career, I would think about, oh, is it continuous or is it categorical or is it binary? But like that's the level at which I was thinking about my variables. But now I can realize how narrow, how that was much. You need to think about that, of course. You need to think about the distribution of variables, yada, yada, yada. But what is actually underneath the hood? What is this variable actually referring to in reality, right? And I hope this typology can help you work through that. So I'm going to stop here and see if there are questions, and then I will do the last part of my talk on Thursday.